Let's now take a look at the pricing PDE for interest rate derivatives. So basically, we're looking at what is the fundamental pricing partial differential equation for financial asset that depends on interest rate. So let's say we have a interest rate process, and this interest rate process is at the risk neutral world, meaning that, say, we use the money market account as numeraire. So suppose in that particular world that the interest rate follows this particular process here, okay? So once you have a risk neutral interest rate process here for this instantaneous interest rate R here. Now any asset, any financial asset that is a function of interest rate can really be written in this way according to Ito's lemma. So as long as it's a function of R, then the process of that the price of that financial asset will be in this form. Now, when you look at it, we'll say, okay, we have a financial asset that follows this process, and in this process is followed in the risk neutral world where the money market account is used as a numeraire. And in the risk neutral world, if you recall that the drift of any price of the financial asset is always equal to R times the value itself. So then what you have is this part is equal to RF. And now you've got a partial differential equation that you can solve if you know the boundary conditions to determine the price of the financial asset. Okay, so now you basically have got the fundamental pricing PDEs for interest rate derivatives. Now, if F is a zero coupon bond, you can then determine the price of the zero coupon bond. If F is a financial asset that depends on the price of the zero coupon bond, you can also utilize this equation as well. Then, so essentially, this equation allows us to price interest rate derivatives, any financial assets that's a function of interest rates.